Today's lesson is kind of like a review, actually, so you guys should find this one very refreshing after the last two that we've dealt with. These are notes for Tight Learning Day 27 and 28, and this is over right triangles and trig ratios, which we already know. So if we just restrict the domain of our trig functions to angles between 0 and 90, you basically are looking at trig functions like a right triangle. So the function values are going to be the trig ratios associated with the acute angles of a right triangle. So let's dilate the unit circle by a factor of r. So we're taking what would have been just the unit circle here, which was going to 1 and 1, well, 1 and negative 1, 1 and negative 1, and we're going to dilate it by a factor of r. So then the terminal side of an angle theta will intersect the circle of radius r in this point xy. And this point xy, instead of just being cosine sine like it was on the unit circle, it's going to be dilated by a factor of r, so it's r cosine theta, r sine theta. Therefore, the trigonometric ratios for a circle for sine theta would be y over r, cosine theta reciprocal r over y, cosecant theta reciprocal r over y. Cosine theta is x over r, secant theta is r over x, tangent theta is y over x, cotangent theta is x over y, because these are the reciprocals of these. Okay, so what can we do with that? Well, let's see. We can find trigonometric values beyond the unit circle. So for a standard position angle determined by the point 8, negative 6, what are the values of the 6 trig functions? All right, so we know how far over we went on the x-axis, and we know how far over we went on the y-axis, but what we really need to do is figure out what the radius is. So to find the distance, knowing 2 points, what do? The distance formula. So r is going to be 8 minus 0 squared plus negative 6 minus 0 squared, which is 64 plus 36, which is the square root of 100, which is 10. Now, we just go back to what I listed on this page, and I'm listing them again. And you just set up the ratios according to the letters, and boom, you solved it. Okay? Like always, if you have any questions about anything, shoot me a remind message, or you can ask me on Google Classroom. I'll re-explain it. You can watch the video a couple times. You can freeze it and slow things down. If we need to meet together live, I'd be willing to do that with you guys as a group or individually if you need my help. So let me know. All right, let's just use points in the first quadrant to make it a right triangle. And I'm talking about trig ratios for a right triangle. So if theta is an acute angle of a right triangle, x is the length of the adjacent leg. Okay, there we go. Y is the length of the opposite leg. Here we go. And r is the length of the hypotenuse. There we go. Then the trig ratios of theta are as follows. So some old hippie caught another hippie tripping on acid. I taught you that in geometry, so everybody should know that. We've reviewed it in Algebra 2, and now we should have that burnt into our memory banks. Cosecant is going to be the opposite, well, the flip, the reciprocal. Hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. So in triangle ABC, which I've drawn down here, angle C is right, and the sine of A is 5 over 13. What are cosine, cotangent, both of A, and sine of B? All right, so first of all, we're going to draw the triangle. So let me speed this up a little bit. Okay, we're drawing the triangle from the clues that they gave us. C is right. Make it right. Sine is going to be opposite, so opposite of A has to be 5, and hypotenuse has to be 13. All righty. So now we've got these two sides in a right triangle. How can we find this side? We can use the Pythagorean theorem, which we did. So 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. Subtract 25 from both sides. B squared equals 144. The square root of b equals 12. So there we go. The square root of b squared, which is b, equals 12. That's how I got it. Okay, now I'm going to put that right here. and I'm going to find cotangent of A. So stand at A. Cotangent is going to be adjacent over opposite, 12 over 5. Cosine of A, stand at A. Cosine is adjacent over hypotenuse, which is 12 over 3. Sine of B, we got to move and stand at B. When I'm standing at B, sine is opposite over hypotenuse. So opposite from B is going to be 12. Hypotenuse never changes. That's going to be 13. Okay, so this part should be super easy for you guys. Again, if you've forgotten something or you need extra help, let me know. All right, the last little bit here is remembering angles of elevation and angles of depression from geometry. Yes, we love geometry, remember that. An airplane's angle of descent into the airport is 3 degrees. If the airplane begins its descent at an altitude of 5,000 feet, what is the straight line distance to the airport? All right, always, let's draw a picture. So here is my airplane. I decided not to try and draw one today. How about that? So I just labeled my plane, and its angle of descent is 3 degrees. We also know that it's at an altitude of 5,000 feet from the ground. So this is what I'm looking at. So let's get a triangle going on so we can do angles of depression, angles of elevation. So I'm going to draw this triangle here, make that my right angle. I'm looking for X. Now, how did I get 3 degrees down here? Well, 2 parallel lines cut by a transversal gives me alternate interior angles which are congruent. So I can say that this angle here is going to be congruent to this angle here. Now I have a right triangle. I know an angle and a side, and I'm looking for another side. So if I'm standing here at angle 3, I can say I've got an opposite and a hypotenuse, which is sine. So sine of 3 degrees equals opposite over hypotenuse, which would be 5,000 over x. So if I do a cross product and then solve for x, I get x equals 5,000 over the sine of 3 degrees. And when I look up the sine of 3 degrees and divide 5,000 by it, I get 95,500 feet. Okay? So this is bringing back geometry and making sure that we remember it. Let's look at another example. In triangle DGH, angle H is a right angle, then our side H is 13 and our side G is 5. What is the measure of angle D? Okay, so I've got my triangle, and I said that H was right and that side H was 13. So we know that that's going to be opposite my H. Then I know that G, which is opposite my angle G, is 5. And I want to know what is this angle here. So I have, if I'm standing at D, I have adjacent and hypotenuse, which is caught another hippie. So cosine of D equals 5 over 13. In order to get the angle, I've got to do inverse cosine. So I'm going to do the inverse cosine of 5 over 13. And when I solve that on my calculator, I'm going to end up with 67.38 degrees. I could have also used Pythagorean theorem and solved to get that side because it's a right triangle and I know 2 of the 3 sides. So that will work also. Remember, if you turn your phone from this way to this way, you get the scientific calculator so you can figure out more of the functions that we need to answer some of these questions. Okay, let me know if something didn't make sense. Get in touch with me and let me clear it up with you, and I will see you guys soon.